Hello everyone, my name is Sam Prajli, and today I will be presenting a comparison between the experimental and simulated temperature data from our heat transfer lab. The main objective of this comparison is to evaluate how accurately the ANSYS simulation predicts the temperature at point 5 compared to what we measure during the practical experiment. Essentially, we want to understand how close the simulation is to the real world data, and if there is a gap, why that gap exists. This comparison also helps us check the reliability of our simulation setup and identify the assumptions or simplifications might be affecting the results. uh, Comparison table. Here we can see the comparison table between the experimental and simulated results. The experimental temperature at T5 measured during the practical experiment is shown alongside the temperature from the ANSYS simulation. We can see that there is a noticeable difference between the two values. The simulated temperature is slightly higher, lower, depending on the case. This difference tells us that while the simulation captures the general trend of heat transfer, it doesn't perfectly match the experimental conditions, which is expected due to several real-world factors such as improper calibration of the experimental setup, humidity, and room temperature, etc. Moving on to the next slide, the reason of the difference other than the heat power. Now let's look at some of the main reasons for this difference apart from the heat power. First, in ANSYS, we had to adjust the heater power to match the temperature at T5. But in the real world experiment, there are heat losses through conduction, convection, and radiation that are not fully captured in the model. Next, boundary conditions. Boundary conditions in Fluent are ideal, meaning the walls are assumed perfectly insulated or uniform, which is not true in the lab. Another reason is sensor placement. In the experiment, the D5 thermocouple might be slightly off position or have minor calibration errors, whereas in the simulations, the probe point is perfectly defined. Finally, mesh and numerical approximations in ANSYS can smooth out temperature gradients, reducing accuracy and specific local points like T5. Altogether, these factors explain why our simulated and experimental results do not perfectly align, but the trends are consistent and similar, which validates our simulation setup. So to conclude, the comparison between experimental and simulated data highlights the importance of understanding both the limitations and strength of the simulation tools. With better boundary conditions and mesh refinement, the results can be made even more accurate. Thank you.